Bismillahirrahmanirrahim. Exercise 3.4, question number 4, part 1. Integral a square minus x square inside under the square root into dx. The formula for integration by parts is integral fx gx, considering f as first and g as second function. It is equal to first function constant integral of second minus integral derivative of first function into the same integral. The previous knowledge which we need here is integral of 1 into dx, which means integral of dx equals to x plus c. Derivative of square root of a square minus x square equals to 1 by 2 times square root of a square minus x square into d by dx of a square minus x square, which is 0 minus 2x. I have written only 2x minus 2x here. This 2 got cancelled, and the result is, that is the derivative of square root of a square minus x square equals to minus x by square root of a square minus x square. We will use this result directly in the solution. And then we need this result. Integral of 1 by square root of a square minus x square into dx equals to sine inverse x by a plus c. This result is evaluated by the help of integration by substitution. And you must learn this result. This is a very important result and it is very often used. Now let's get to our integral. Let integral I equals to integral square root of a square minus x square into dx. We introduce a 1 here and we write it like this. I is equal to integral square root of a square minus x square into 1 into dx. And now we are going to perform integration by parts, considering this as the first function and this one as the second function. This will be our second function. Now let's perform integration by parts. We are going to integrate by parts, and the result will be integral I is equal to first function constant, integral of second minus integral bracket starts derivative of first function. Excuse me, these expressions got merged. I must erase and write these again. D by dx of square root of a square minus x square into the same integral, integral 1 dx bracket close, and then I have a dx. So I get square root of a square minus x square. This result is x integral. This is minus x by square root of a square minus x square, as we discussed here, and then integral dx is x, and then comes this dx. So I get x into square root of a square minus x square minus, keep this negative sign inside and write it like this, minus x square divided by square root of a square minus x square into dx. And now what I'm going to do, I'm going to write it like this, and all these integrals I must keep writing my I here because I'll be needing it shortly. X into square root of a square minus x square minus x square divided by square root of a square minus x square and a dx. And what I'm doing here, I'm adding an a square and I'm subtracting an a square. Add and subtract an a square in this numerator. Now let's split it, x into square root of a square minus x square minus integral, write a bracket here and split it into two fractions, a square minus x square divided by square root of a square minus x square minus a square divided by square root of a square minus x square bracket close and a dx. Now what about this one? You must remember this result from basic algebra, that it is equal to x, this thing, x by square root of x is equal to square root of x. Apply it here and let's see what we are going to get. The integral I is equal to x into square root of a square minus x square minus integral, inside the bracket I have square root of a square minus x square minus a square by square root of a square minus x square, bracket close, and a dx. Now open up this bracket and write the two integrals. Let's see what you will get. You are going to get integral I is equal to x into square root of a square minus x square minus integral square root of a square minus x square dx. I am opening this bracket. So minus integral a square minus x square under the square root into dx, the first integral, and the second minus into minus plus. And I am writing this a square outside the integral because it is constant. We can write it outside the integral. And inside the integral, I have 1 by square root of a square minus x square and dx. It is your choice. If you don't like it, just keep it, inside the integral, and in the next step, you can take it outside. I have done it in one step. And now what? What is this integral? Just have a look at this integral and compare it with our first one. You can see this is our integral I. Integral I was integral square root of a square minus x square into dx. So in place of it, write I. Your result will be I is equal to x into square root of a square minus x square minus I plus a square. And what about this one? Use this result here and you will get sine inverse x by a plus a constant of integration. Now it's your choice here, girls. If you want to write directly C1 here, it's okay. And if you want to write it like this, that you need a bracket here, if you use a bracket here, then it will take this shape. And then our constant will be a square into C1. It's your choice whether you want to use it inside the bracket or you use it without bracket. If you write without bracket, you may see that you will get this thing. Again, you have a constant. If you write inside the bracket, you will have this thing. Here it is. Why doesn't it make any difference? Because it is an unknown constant. It won't make any difference in the long run. But right now I'm using it inside the bracket. So let's see, what do I get? I am going for my next step. Bring this I towards this side. On this side, you will have I plus I. When you bring this I on this side, you will have I plus I. I'm writing it directly as 2I. When I bring this I over to this side, I get 2I, and here I have x into square root of a square minus x square plus a square sine inverse x by a plus a square c1. And now divide both the sides by this 2. You will get I is equal to x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a, and then plus a square by 2 c1. Now put a square by 2 c1 is equal to c, and what will be your answer? It will be equal to, the answer will be x by 2 into square root of a square minus x square plus a square by 2 sine inverse x by a plus a constant of integration. And that completes the result, and this is our answer. Let's see this thing once again. If I have used only C1 here, I haven't used a bracket here and I have used only C1 here, then I should have a C1 here and a C1 here, and here I have C1 by 2, and then I have put C1 by 2 equals to C, and I would have gotten the same answer. Technically, this is the correct way, but even if some student don't use the bracket and directly introduce a constant here, that is not also wrong, because the value of the constant is unknown. So it's your choice. Okay, take care.